Good afternoon, Senior 2 students. We're still in Chapter 2, Lesson 3, Part 2, Metallic and Non-Metallic Property. We stopped at the graduation of acidic and basic properties in the modern periodic table. In the group which starts by a metal, by moving from up to down by increasing the atomic number, the basic property increase. So you can find that weak bases are at the top, and by increasing the atomic number, the basic property will increase till we reach the strongest base, which is cesium hydroxide. This is because by increasing the atomic number, the atomic radius increase. So the bond with OH group becomes weak, and the separation of negative hydroxide group will be easier as the atomic size increase. In the group which starts by a non-metal, as we move from up to down by increasing the atomic number, we have here group 7A that form a type of acids called halogenated acid. By moving from up to down, the acidic property increase. By increasing the atomic number, the atomic radius increase, so the bond with H positive becomes weak, so the separation of H positive becomes easy. For elements of the same period, the basic property of oxide decrease as the atomic number increase. So as we move from the left to the right by increasing the atomic number, the basic character or the basic property will decrease, but the acidic character will increase. Acidic and basic property of the hydroxy compounds. Hydroxy compounds are compounds which contain OH group. Like the oxygenated acids, acids which contain oxygen are called oxygenated acid. And bases that contain negative hydroxide group, both of them are called hydroxy compounds. They can be represented by the general formula MOH. M stands for any element, metal or non-metal, while OH is the negative hydroxide group. These compounds can be ionized in two ways. In case of acid, we have here two types of bond: element attracted to oxygen ion, and hydrogen is also attracted to the oxygen ion. In case of acid, the bond between the element and oxygen is stronger than the bond between hydrogen and oxygen. So it will be ionized as in the following equation. In case of base, we have the bond between element and oxygen, and also the bond between oxygen and hydrogen. But in this case, OH bond is stronger than MO bond, so it will be ionized as positive ion and hydroxide group. If the attraction force between both of them, M and O, equal to the attraction force between O and H, so the substance will be ionized as an acid or as a base according to the medium of the reaction. The second note here, the attraction force between oxygen ion and hydrogen ion, and the attraction force between oxygen ion and element depends on the volume of the atom, M, and the charge that found on the element. Oxygenated acids are represented by the following general formula, where M is the central non-metal atom, O is the free oxygen which is not bonded to hydrogen, and this N refers to the number of free oxygen atoms. OH is the hydroxide ion, and M refers to the number of OH bonded atoms. The strength of oxygenated acids depend on the number of oxygen atoms which is doesn't bonded with hydrogen atom. When this number of free oxygen atom increase, the strength of the acid increase. Let's take some examples for the oxygenated acid and know the strength of each of them. The first example here, orthosiliconic acid, its molecular formula H4SiO4. Its general formula Si, and all oxygen are bonded to hydrogen atoms. So there is no free oxygen atoms, and this acid is very weak. The second example, orthophosphoric acid, H3PO4. We have here only one free oxygen atom, so its strength is moderate. Sulfuric acid has two free oxygen atoms. It is classified as a strong acid. And finally, we have perchloric acid, which contain 3 free oxygen atoms, and it is classified as very strong acid. Thanks for listening, Senior 2.